Okay, physics students, I'm on page 92 of your textbook, and this topic is adding vectors that are not perpendicular. If they're not perpendicular, then we don't have any formulas for determining the hypotenuse or the resultant, because we don't have a Pythagorean, because there's no right triangle. So what we want to do is show you a trick that we can use to create a right triangle and use Pythagorean, and then we could resolve the resultant. Here's an example. Here's an example problem. A plane flies 120 kilometers southeast at 45 degrees and then 50 kilometers east. Now, if it just says 50 kilometers east, we'll just assume that this is flying directly east. All right. What is the magnitude of the resultant and the direction? Okay, so there's no right triangle here. I'm not going to draw this to scale, and primarily because I just simply don't have I don't have time to do that. So here's my x, and here's my y. Let's just assume that our airplane was flying 45 degrees southeast. So if it was flying 45 degrees south east, here it's 45 degree angle, and so here's our vector, which we know this is 50 kilometers, and then it flies due east. No, this is 120, excuse me. This is 50. And then it just flies due east 50 kilometers. And we want to know this resultant. Alright, we want to know the resultant. So this is what we're basically going to do is we're going to move this vector, and we already know that we can move these vectors around. We're going to imagine that this vector is right along this x-axis, and then if we move this vector right along this x-axis, then we have a right triangle, don't we? Okay, so here's our x-axis, and now we have a right triangle. So we'll just call this x1. So we'll resolve this vector to x, and then this will be x2. Well, we already know that one's resolved for us. It's 50. And then we'll resolve y. Right, and then we'll have a right triangle. Once we get the right triangle, we can get the hypotenuse. Once we get the hypotenuse, we could use inverse of tangent to find this angle, and that's how you do it. So x1 equals 120 kilometers times the cosine of 45 degrees, and that equals 85 kilometers. And then the x2 we already know, that's given for us. It's right on the x, so there's nothing to resolve. And then y1 is 120 kilometers times the sine of 45 degrees is 85 kilometers, and y2 is 0. There's nothing to resolve there, so we could write it y2 is 0. It's important to write it because in other examples you will have a y2. So that's why I wrote it. In ours we did not, but in other examples you will. So the adjacent side is going to be x total, which is x1 plus x2, and that's 85. That's 85 plus 50 or 135 kilometers. I should practice what I preach and give my units. Alright, so y total is y1 plus y2. We know y2 is 0, but we want to be in the practice of writing it, because we're going to have to do it again. I'm not surprised that both these are 85, because it's a 45 degree angle. If it's so if it's a 45 degree angle, then they're going to be equal. So it's not a coincidence. It's because it's a 45 degree angle. All right. Now let's draw our triangle again. And in the interest of time, I'm drawing it quickly. So it came down and then it flew east. Here's our hypotenuse. And in order to get the hypotenuse, what we're going to call is d, because that's the displacement, that's the distance we want. D is the square root of 135 squared, and you know where I got that, plus 85 squared. You know where I got that. We're just using Pythagorean here, and 160 kilometers is the magnitude. So we have our magnitude. So that's d. That's the magnitude of the vector. Now we need direction, and that's gotten by the inverse of the tangent equals opposite over adjacent. And we got that from the trigonometry relationships that we should know, and SOHCAHTOA. Perhaps you remember SOHCAHTOA. So 135 divided by, and those are kilometers, 85, and then the inverse of tangent, and that should equal 58 degrees. So this is 58 degrees, isn't it? Well, because it's opposite of the angle that we're interested in. But that's kind of awkward. So really, what we want to do is we want to say southeast. And so let's go ahead and subtract that from 90, and call it 32 degrees southeast. That makes more sense than 57 degrees. How would you say this? North of southeast? I don't know. Anyway, southeast would be. We usually go clockwise. That's the issue. All right. So the answer is 160 kilometers, 32 degrees southeast. All right. Okay, so briefly, I'm out of time, but if you find page 94, practice C. I'd like for you to give this a go. Now, in this example, what you're doing is very, very similar, because it's a plane, 2.5 kilometers, angle of 35 degrees, changes direction, just as we did. So it's this plane just changes direction, and what you want to find is this. You want to find this, the magnitude and direction of this. All right, that's basically what we did just now. So you would do the same thing we did. You would resolve this to y. You would resolve this to x. Then once you have these values, you could use Pythagorean. So I should write that. So resolve y and x to make a triangle. Use Pythagorean to find d, which is, of course, that's d. That's our displacement. And then 3 use the inverse of tangent to find direction. And your answer, I don't have time to work it out, your answer should be 7.5 kilometers at 26 degrees to the ground. Alright, 26 degrees to the ground. Alright. That should be your answer when you work it out. And I'm out of time.